everybody, Kristen here for today's Tuva Science Connections, titled Stars plus Distance equals Brightness, where we're looking at sort of using data to get into the performance expectation 5 ESS 1-1, where our students are trying to support an argument that the difference in the apparent brightness or the magnitude of the sun compared to other stars is due to their relative distances from Earth. So in order to make that comparison, we need to have a better understanding of what's going on with other stars and how their brightness, that apparent brightness, differs or relates to their distance from us. And we can use a data set of lots of other stars to kind of give us a sense of what's going on with other stars. So we can ask questions like, how far away are the brightest stars in our universe? Does the brightness of a star suggest anything about its distance? And so to do that, we'll be looking at this starlight star bright data set. And let me jump in so we all can see it. So these are data from Dr. Jim Kaler at the University of Illinois. And what we have in this data set are 36 cases or 36 stars in the universe. So by no means every star there possibly is, but 36 is still a good number for us to look at and look about some relationships. And we've got information about 5 different characteristics of these 36 stars. So we have their star name, the apparent brightness, the distance from the sun, the star color, and the star temperature. So there's lots of things that we could explore within this, but we're sort of here to talk about the apparent brightness. So let's drop apparent brightness on this axis, and then let's talk about apparent brightness or magnitude. This is a super interesting attribute of stars that has a really interesting history dating way back when, which can be really fun to explore with your students. The key thing is that the axis is in essence reversed from what we're used to. And so often we think of higher numbers means better things, bigger things, right? But here actually a higher apparent brightness or a higher magnitude actually means that it is dimmer. And so what I'm going to do is I'm going to kind of put a note, a big D, so we can remember that these stars are dimmer, which means the stars on our other side of our axis, these stars are brighter. And thanks for bearing with me with my funny, my funny drawings of letters. But just sort of as a reminder, our brighter stars are down here and our dimmer stars are up here. And so we can think about, right, our question is, how far away are the brightest stars in our universe? And so what we can use is we can color the points by the distance from the sun that these 36 stars are. And we know that our nearest ones are in green and our farthest ones are in orange. Coming back to our axis of apparent brightness, we can sort of arbitrarily decide, or, you don't necessarily have to arbitrarily, we could say, okay, anything from 0 down are our brightest of the bright stars. Okay, so we've got 0 to 20 light years away, 101 to 500 light years away, and what's this blue color? 21 to 100 light years away. And there's like one sort of squeaked in just over the 0 here at 501 to 1,000 light years away. Okay, but in essence, what we have is that our brightest stars within this data set are from 0 to 500 or 1,000 light years away. And then that second question was, is there a relationship, right, between the brightness of the star and how far away it is? And so let's dive into this even further and let's plot distance from the sun as its own variable. And I'm going to kind of move these B's and D's up so that we can look more at the data and they're not in the way. So one thing that jumps out that we could see on that unidimensional dot plot, but it's sort of even easier for my eyes to see it now that we've got distance along the y-axis, is that there's a big variety of brightness, apparent brightness of stars that are within 0 to 20 light years of the sun. That's pretty interesting. But it makes it harder to figure out, okay, so what's another relationship that we might be seeing? So we can take this, the nearest stars out of the data set so that they're no longer kind of confusing us. And now it looks like, oh, maybe we do have a relationship. What else could we add here that might make it a little bit easier? Okay, so we could plot this movable line, right? We're not actually looking at calculating any sort of significant relationship, but we're just kind of using these annotations to help our eyes see through where the dots are. And what we have is sort of these These stars that are dimmer, remember, seem to be the farthest away, and that these stars that are brighter tend to be closer in. And so, what's interesting with that is that using these data, we've now gotten a better sense of kind of how brightness and distance might be at play for some of the other stars in our universe, which can help us then make comparisons to our sun. So, how far away are the brightest stars in our universe? Well, of these 36 stars, right, we said they were somewhere between 0 to 1,000 light years away from the sun. Does the brightness of the star suggest anything about its distance? Well, remember those stars within 0 to 20 light years within this data set had a pretty large difference in their apparent brightness. But when we looked at stars within sort of 21 to 1,000 light years away, then we started to see that generally the brighter stars are closer to our sun than the ones that are farther out. The farther out ones tend to be dimmer. But it's not a perfect like one-to-one relationship. There's some variability there. So if you're interested in this or any other of our Earth and space science data sets that can support those performance expectations, I encourage you to go check out the Science Content Library. And with that, enjoy your day and have lots of fun playing with the data.